task number 2 will involve something of a similar nature to task 1, except it will be controlled via electrical controls, so electro-pneumatics and relay control. And then task 3 will involve another build upon from task 2, and will involve this time PLC control. I'm going to do and deliver training for all 3 tasks over a series of videos. The Fluid Sim software that I'm using, I'm going to make available to you via Dropbox. It's a student version, I think, anyway. So I'll make that available to you. Just as a background to the software, this is your main desktop working area. You've got a hierarchical view, or component library as it's called. You can remove that out of your way. It can be quite cumbersome to find parts within lists, looking through certain parts. It's typically a lot easier if you learn what the components are called. If you haven't studied the automation fluid power unit, or you haven't done level 3 pneumatics, hydraulics, or applications, pneumatics, hydraulics, devices and circuits, you would definitely benefit from having a look over some schematic symbols and their names. I'm going to be removing this out of the way for the purpose of what we're doing. I'm going to be working with a clean workplace, so new, or control N, will bring you up that. You can set the drawing size just for your own reference. We go into File and Drawing Size. Currently I have it set up under A0, one of the largest ones available. I think by default it's set under A4. If I press OK, you'll see that the drawing size changes in the line of the size of the drawing. I'm not overly concerned about the size. I'm not going to be printing this off to anywhere. So I'm going to leave mine big so that I'm not limited by space of where I place components. So I'm just going to move this back up into a large size again. So task number 1 will involve basic pneumatic sequences. I will release some other videos to you as well for some basic pneumatics I'm covering from some of the work I've done within the automation fluid power unit, within the foundation degree, electrical, electronic and mechanical manufacturing engineering. But I'll make a start. On this particular piece of software, I'm going to use F3, and it will be define component. We'll bring this up. You can do this probably via the top somewhere as well. I don't really use it very often, so it's under Insert and then Find Component. I just use a shortcut key every time of F3. So we're going to begin with a very basic circuit, and it's going to be, and I'll outline what it is by text. So it's going to be A plus, B plus, A minus, and then B minus to finish off. Just bracket that term. And you just need to get used to being able to read a sort of list of components like this and realize what the sequence should be. If they're side by side, like so, and separated via commas, one happens after the other and they're sequential. If, for instance, A plus had B plus below it, or beneath it directly, then a comma, it would mean A plus and B plus happened at the same time. So you can think of from left to right as like an x-axis in time. Therefore A plus should happen first, then B plus, then A minus, then B minus. So it's safe to assume from this particular circuit that if A goes plus and then the second thing to happen is B goes plus, then it's safe to assume that both cylinders start off as retracted. So let's try and build this up. For this particular circuit, we're going to work with 2 double acting cylinders, A and B. They're going to be controlled via 5-2 pilot air operated valves, and then the overall system will be controlled via roller switches, which are pneumatic 3-2 valves, and then finally there will be a pneumatic 3-2 push button activated valve to control the operation of it. This will all be detailed to you in the task, so don't be worrying about that. So let's get some components in. Double acting cylinder. There is 2 available on the components. I barely know the difference between them, so don't worry yourself. It just seems to be a file name for whatever reason. Neither of them do anything different. this, and then the position you're telling the software at which positions A minus and A plus would trigger an external roller switch in our case. So a double acting cylinder within this software is 100mm long, 10cm. So A minus will happen only when it's fully retracted, and A plus will only activate when it's fully extended. Do something similar for B as well. B plus 100 and 100, and we have B minus 0 to 0. So both of these are now able to be set up and controlled and activate roller switches now that they have this external piece of information about their position. So we're going to need a set of 3-2 roller lever switches, and we want the one that is normally closed. Okay. And we're going to need 4 of those. So I'm just using the copy and paste features. I'll not label them just yet until I get my 3-2 push button in. So I'm searching for 3-2 valve with push button, and make sure you get the one that is normally closed rather than open. And then I need an air supply for each of these, and I also need 5-2 valve to control the overall directional controls of the 2 double acting cylinders. So let's get those in. So 5-2. So it's the first one that comes up. It's an impulse valve. They've also got spring return valves and D10 switches, which is the sort of rotary switch activation. So place into your particular circuit these 2 components, copy and paste the second one in. So what you should be able to achieve now, although we're building this in software, you'll be building this in on the Festo rigs. What you should be looking to do is have your actuators at the top, and then the control sequences for those directly below. The control for the circuit, as in how it operates in what particular order, and then activation down the bottom, and then below that again you'll have air supplies and so on. This is just for drawing, it's just sort of rule of thumb, professional practice, and it's just good to follow. One of the last components we should need is an air supply. So we can supply our air to our 3-2 push button valve. Now, in a sequence like this, A plus B plus A minus B minus, whatever component is at the end, so B minus, you need to use that particular sensor in series with whatever starts the sequence to activate the first part of the actual sequence, which in this case is A plus. So the first thing that should happen is A should go plus. So to make A go plus, we need to obviously activate port 4 from this 5-2 valve, which would make A extend. That means we need to activate port 1-4 here via the 3-2 roller switch, which should be then labelled B minus. And you see here, as soon as I label it, it shows the activated position because B is currently in its minus position. And I can activate that like so. So I could test this part of the circuit straight away just to show you. So, yep, a whole pile of open connections, I'll just ignore them, start anyway. And you see the software drops back into a certain position. So as long as B is in the minus position, I'm able to press that particular one, and you see that B minus activates and supplies an air supply into 5-2 valve. So all I need left to finish off is to activate this particular one to give it an air supply through. And you should see A then extend. So I place on to the circuit a wing of compressed air, supplies, so if you want to search for it, compressed air supply. And let's get a couple of those placed onto the diagram. Let's just tidy those up a little bit. Again, I can ignore the open. I'm just looking to show the principle here. Press the push button, and you will see that B minus is obviously activated here, which then makes A go positive. Okay, and it stays in that extended position even when I let go of the 3-2 push button until obviously it's triggered back to auxiliary. So we need to finish that off. So that makes A go plus. We then need to make B go plus. We want to make the B go positive only when A is fully extended. So we need to use, for instance, then let's just try and move this over to centralize it. Then need to use these components here. So when A is in the plus position, it should then make B go plus. So we activate it via this here. The A plus sensor activates the 5-2 valve controlling the B cylinder, which then makes it extend. So let's just have a look at what's happening so far. Yep, let's just ignore these connections. And so if I press the start button, see A goes plus, and then when A plus activates this sensor here, it then extends B. So A plus has happened, B plus has happened. We're now looking to make A go back in again. So you make A go back in again when B is fully extended. So stop the circuit. This is going to be via here. This here will then be B plus. So when B is in the plus position, it will make A retract back. So let's have a look. And again, ignore the open connections just to see what's happening. Press the button, A goes plus, B goes plus, and then you see A going to minus again. I can then finish it off that when A is in the minus position, it will then make B come back in. What we're able to do is actually able to slow it down so we're able to witness it. We go to options and then simulation, slow motion factor, change it down to something like 1 to 5 will be fine. And I'll be able to hit play and watch it run a little bit slower motion. A plus, B plus, A minus, B minus, and then it's sitting waiting to be started again by the start button. So A plus, B plus, A minus, B minus. All fairly simple, not too many connections to be made, and very few mistakes should happen with this particular type of circuit. So this is circuit attempt number 1. Before we include any